one discipline. However, I would be focusing on engineering to emphasize the role that engineers can play in terms of creating smart cities. Now, we have seen this slide. We have seen this slide many times, the UN Sustainable Development Goals, the SDGs. And if you look at these 17 SDGs, I could easily count more than half where engineering can play a very direct role. And also the remainder, again, engineering has a role to play somewhat indirectly. But the fundamental issue is, when you look at this Sustainable Development Goals, it's about the water, food, energy nexus. So it's about human well-being, it's about human dignity, and we need to remember that it's primarily focused on human dignity. Now, when I talk of smart cities, I would be using the word urbanization and cities intermittently. So in other words, I see cities and urbanization in the same context. And you have seen some of these facts and figures previously. So at the moment, as of today, or I think it was in 2016, there are more than 50% of the world's population is urban, and the prediction is by 2050, not just a few years' time, the world, something like 2/3 of the world's population is going to be urban. And cities, though they occupy only 3% of the land, they have a very significant footprint in terms of resource consumption, in terms of waste generation, in terms of emissions. So as you can see, so I won't use that again. So for example, cities are responsible for 80% of carbon emissions. And currently 850 million people live in slums. So just imagine, we have a world population of 7 billion or 8 billion maybe now, and close to 1 billion people are living in substandard housing. They don't have, in terms of human dignity, what do they have? And in 1990 there were 10 cities with more than 10 million people, and by 2014 the number has reached 28 and is increasing. So when you talk of increased urbanization, remember at the moment it's around 55% of the people live in urban areas, and in another 30 years time we will have 2/3 of the people living in urban areas. So if you think of the challenges that this poses, shelter, how do we provide adequate housing to this increasing population? Because remember, it's not the percentage of people going up, but also the number of people. The population is increasing, so and with that increase, you have got 2/3 moving into urban areas. So how do we the previous slide said, we are close upon 1 billion people who are living in substandard housing. So when the urban population increases, the challenge is how do we provide adequate housing to these people? Infrastructure, so water, sewerage, roads, energy, health, education. How do we provide adequate infrastructure to this increasing population? And how do we handle increased waste, liquid, solid? So this is only looking at the engineering context. Of course, there are other challenges. And if you look at the current urban paradigm, so we have got our urban area there, and what an urban area does is it sucks in a lot of resources and emits. So we suck in a lot of other people's resources and emits a lot of waste, solid liquid waste and emissions. So if you think of the current urban paradigm, and if you think of an urban area as a living organism, this is a clear analogy of a parasite, sucking in resources and putting out waste, which then becomes the responsibility of somebody else. And let's look at this. Is this sustainable in the long term? Can we maintain this paradigm? Or should we be looking at changing this paradigm? So, listening to the various presentations yesterday and today, and if you think of, I was trying to define what a smart city should look like in my own words. So it's about meeting the needs and aspirations of the population. In other words, giving that the concepts of human well-being, human dignity, etc. But the Sustainable Development Goals wants to achieve is about a sustainable consumption of resources. Sometimes what we forget is resources, whether it's land, water, energy, etc. is finite. So how do we sustainably consume resources? And it's about adaptation to climate change, and it's about resilience to natural disasters. Though I put them as two separate points, they do tend to go together because there's enough longitudinal studies that have been undertaken around the world. In fact, the previous session also mentioned it. There are a lot of longitudinal studies that have been undertaken which shows that the frequency and magnitude of natural disasters are ever increasing. So how do we build resilience to those disasters? How do we make the community resilient? And I'm not talking being sustainable. Resilience goes beyond being sustainable. You need to be sustainable. That's the first step. That's the initial step. But to be resilient, you need to go beyond being sustainable. You can be sustainable, but not necessarily resilient. I'm happy to discuss that at a later point. And it's about minimizing waste, conservation, reuse, recycling. So the question I want to discuss today is how can engineering contribute to achieving these goals of a smart city, the aspirational goals of a smart city. Now let me show you some, I don't know how many of you all, we read about climate change, but how many of you all actually seeing climate change in action? The sea level rise, the increasing temperature, etc. So let me show you some, in case you all are not experiencing climate change, let me quickly show you a few photos. I have spent a lot of time in Indonesia. Now, if you know of Indonesia, it's an archipelago of 15,000 islands. Actually, the Indonesians don't know how many islands they have. When you ask them, they say, we have got about 15,000 islands. So, having a country of 15,000 islands, you can imagine the length of their coastline. And so what you see is inland as at day. Now there's a lovely little farming village. You've got rice fields around, and those houses in the middle, that's where the farmers live. That was about 10, 12 years ago. Now, that's what this place looks like now. Nobody asked the question, what happened to those people? What happened to their livelihoods? What happened to their land? So what dignity are they left with? And this again, Semarang. So what's happening is, you have got this, water is coming to people's homes and is standing water, not due to high tide, is standing water. So what people are doing is, they are putting timber and raising the flow. So as the water level rises, they keep on raising the flow. Now there are houses in this area, the height between the floor and the ceiling is so short, you cannot actually walk inside. So what people are doing is they are living during daytime, they are living on the street and they come into the house just to sleep. So this is what climate change is doing to various cities. That's a fairly affluent house. You can see they have got air conditioners up on their second floor, but the ground floor is underwater. But people are still living there. Now this is a fish market. Now you can see that lady in that hat. She's standing in knee-deep water, just permanent water, and that's how she earns a livelihood. So how would you like to come into work and having to stand in knee-deep water? And that's a fact of life. Now this is the port of Semarang, which is the second largest port in Indonesia. The largest is in Jakarta, the second largest. And the port is going underwater. I don't know whether you can notice. So what you have is a container, there's a container truck there. So it's a truck repair yard. And can you see on top of that, on that truck, there is a man working there. So these people they're coming into work, they're working standing in water. Now, so that's what climate change is doing to various parts of the world. So this is how some people in some parts of the world are already experiencing climate change, and as you can see, there is no resilience. There is no adaptation because they are poor. If you are rich, you are fine. I think that's the biggest problem with climate change. I mean, same as what we heard in various panel discussions, etc. Because there is climate change, there is no social equity in climate change. Everybody is not affected the same way. If you are rich, you have got the resources to adapt. If you are poor, too bad. So whether it's individuals or it's countries. If you are in a rich country, you don't need to name those countries. If you live in a rich country, yes, you have got the resources to adapt. If you live in a poor country, like Indonesia, there's nothing you can do about it. Now, so that's climate change. I think the other aspect we need to keep in mind, if you want to achieve those aspirational goals of being a resilient city or a smart city, is our own consumption. You may believe in climate change, you may believe in the need to adapt, you may believe in sustainability, but I wonder, we as individuals, I wonder how well we know our own footprint on the environment. By the way, I'll talk of water because I'm a water engineer, so I'm not making any excuses. So when we talk of water, and when we talk of our impact on the environment, on the water environment, I wonder whether you are familiar with the concept of virtual water. So in other words, how much water do we need? What is the total amount of water we need to produce certain goods and services? So for example, Australia is an agricultural country, so is Brazil. Now, would you believe me if I tell you Australia's biggest export is not wheat or beef cattle or tea, it's water. Because we use so much of water, something like 70% of our fresh water is used for agriculture. And we are exporting our agricultural produce to various countries around the world, like Japan, etc., who already have more than the water they need. So, as an agricultural country, you tend to export water because of the water we use for agricultural production. So that's the definition of virtual water. It refers to the amount of water required to produce goods and services. So just take an example, a practical example of, say, all of us had coffee just a few minutes ago. How much water do you need to produce a cup of coffee? And if you tell me you need 1 cup of water to produce 1 cup of coffee, you fail. Because the coffee beans don't drop from the skies. You need to grow the coffee plant. to produce those coffee beans. And if you have coffee with milk, well, you either get the milk from a cow or it could be soya milk. You have to feed the cow, you have to grow the soya beans, etc. So this will give you an idea of your ecological footprint. So my apologies for the size of the font. What you see is coffee up there, the top line. And because the font is small, let me read it to you. So to produce 1 liter of coffee, you need 1,100 liters of water. And if you are feeling guilty, and maybe you drink orange juice. And to produce 1 liter of orange juice, you need almost 1,000 liters of water. And an interesting thing is beer. If you have beer, you only require 300 liters of water for 1 liter of beer. So maybe the conference organizers can take note of it and we can have beer tomorrow morning. Okay, I'm getting a lot of thumbs up from the audience. So the point is, we need to be conscious of our own ecological footprint. So I am only talking about water here, but think of the energy, etc. that goes to produce that coffee, that goes to produce that orange juice, that goes to produce that beer. So now let's look at the common problems that are associated with today's cities. The paradigm I was talking about is about ineffective handling of waste leading to pollution of water, air, soil. Because our current paradigm is we produce the waste and we push it out into another area. Somebody else has to solve that problem. It's about inadequate infrastructure leading to congestion, lack of services, and social inequities. Because when we talk of inadequate infrastructure, everybody is not affected the same way. It's about the inequitable distribution and unsustainable consumption of resources. It's about the low resilience to natural disasters. There are numerous examples around the world where people are still living in relief camps, refugee camps, even 10 years after a natural disaster. So that tells you how resilient some people are or some cities are, and substandard housing. It's a common issue. It's a common issue also in Australia. Housing affordability is a major political issue. So please don't bother to read the lettering. So it's, when we envisage a smart city, so it's about having this interconnected system. So it's about making sure that the energy system, the water supply system, the transport system, all of these are integrated, because our world is becoming more and more complex. Our systems need to be integrated. And what happens is our systems, if one system fails, then everything else fails. You have got your cascade of failures. So what a smart city should be doing is making sure that these systems are integrated and they are resilient. So in my opinion, the key features of a successful smart city is smart citizens, very important. It's about good governance. It's about data collection and management excellence. So it's not about collection of data, it's about collecting the appropriate data, analysis, and applying that for decision making. As I said before, it's about integrated and shared frameworks. It's about efficiency and sustainability. So we need to have all these things well integrated for us to achieve those aspirational goals of a smart city. And we don't need to name the cities. I cannot think of a single city that has any of those features, or maybe we might have a few of them but not all. So when we talk of a current or a modern city, or what we call a modern city and a smart city, we are talking of a lot of challenges. So coming back to my own profession as an engineer, I think there's a lot of enablers for us to achieve those goals of a smart city. It's about the digital evolution. So we have got more and more organizations, companies, governments adopting digital tools, digital technologies. So that's a major enabler. It's about unlocking data. We have always collected data. So whether it was filling paper forms or electronic documentation, etc., we have always had data being collected. But it's about unlocking that data. It's about sharing that data, analyzing that data, and helping in this community. And we should not forget the fundamental engineering principles. Now, as a water engineer, some of the principles I apply today is more than 100 years old, but they are still relevant, and the advantage is with today's technology, we can apply them better, we can understand them better. And it's about improved optioneering. Yesterday it was mentioned that we need to be aware of the unintended consequences of our decisions. So optioneering is about giving you that ability to look at a range of options, because we have got computing power, we have got various analytical tools such as artificial intelligence, machine learning, etc. So humans are clever, but there is a limit to the amount of information they can assimilate. There's a limit to the amount of analysis they can handle. Computers can do it better and much faster. So we have got all those tools available to us, those technologies available to us. And it's about collaborative practice. I think this was emphasized over and over again at this conference about the transdisciplinary approach, the need for professions to come together and to solve and to work for the common good. So the underpinnings of smart engineering is about, so the fundamentals of smart engineering is about data, big data. There's a term we hear being used very regularly now. It's about data mining, capture, analysis and application. It's about using various innovative technologies. It's about real-time monitoring and the Internet of Things, which is becoming more and more popular. And quite importantly, scalable systems and infrastructure. Now, unfortunately, engineers have not been too good at that, because, I mean, yesterday, Tan was mentioning about, or somebody was mentioning about this second bridge that's being constructed or just about to be opened, connecting the island with the mainland. Now, what would the life of that bridge be? I'm not talking about the engineering life, the usable life. Will it still be usable, or will it still give you adequate transport as it is in 25, 30 years' time? Maybe not. But how do we increase the capacity of that bridge? Have the engineers thought about that? And this is something we need to think about. Our infrastructure needs to be scalable. So as the demand increases, as the population increases, we need to be able to expand our infrastructure. And also this use of new and smart materials, they are becoming quite common now. Mostly, one is to economize on our cost, and secondly, to reduce the carbon footprint. And it's about resource conservation, it's about waste minimization, reuse and recycling. So let me quickly expand on those underpinnings of smart engineering. So it's about using sophisticated So we have got all these methodologies, tools, etc., and computing power. Now examples are where you can provide, using that information, those tools, you can provide better services and improve well-being. Now Queensland, I think it was this year, we adopted the e-health concept where all our medical records are being made available electronically. Now, I'm sure some cyber security experts will talk about privacy, all those issues. Those issues are there, they are not going to go away. We might still have Google, everybody's spying on us, but I'm not going to talk about that. But if our medical records are available electronically, say I fall ill, I hope not, here. So, and if I were to get into hospital, the Brazilian doctors will be able to access my medical history instantaneously. So, in other words, you can provide better customer care, better health care.
Pelos municípios. A segunda parte são os apoios ou as induções, os estímulos que podem vir dos governos estaduais, regionais e do governo nacional. E ainda se forem coisas maiores, podemos pensar em financiamentos internacionais, que vão ser buscados pelos países na medida da necessidade que venha a ser sentido por essas cidades. Mas olhando para isso, então, é claro que nós também sabemos que aquilo que for planejado, utilizando-se dos objetivos do desenvolvimento sustentável, hoje, por exemplo, que passam a ser o nosso grande norte, a nossa utopia maior, mas que gradualmente, se eu procuro essa utopia, eu vou alcançando patamares. E com esses patamares eu terei condições de acompanhar o que estou fazendo, avaliar o que está sendo obtido e, a partir daí, que resultados, de fato, poderão ser configurados como aqueles que permitirão, então, serem contempladas todas as questões que o professor ali colocou. E ao olharmos para isso, portanto, entramos no aspecto de que, se eu tenho uma execução, eu preciso ter acompanhamento e controle. Ao destacar isto, a necessidade de acompanhamento e controle, significa que eu preciso efetivamente ter um sistema de informações que esteja disponível, onde todos os elementos associados ao que está sendo feito, como está sendo feito, no tempo, no espaço, no território, no componente financeiro, devam estar disponíveis transparentemente para a sociedade. E que, ao acompanhar o que está acontecendo, se pode executar em função das prioridades que são estabelecidas, ouvida a própria sociedade nas participações sociais, por meio das audiências públicas e outras formas que cada municipalidade poderia encontrar. Quando olhamos para isso, portanto, eu queria destacar, dentro desses aspectos, o primeiro componente que eu mencionava, o ser humano e as principais demandas, que nós poderíamos colocar em seu trabalho. Eu estou olhando aqui para a necessidade de como estabelecer no planejamento a habitação, a circulação, o trabalho e a recreação. Eu acho que vale a pena destacar aqui algo que nós precisaríamos mudar em relação ao que significa. O H de habitação é o mesmo H de humilhante. Quando nós verificamos, por exemplo, apenas para ficarmos numa ilustração, em que a cidade de São Paulo, a cidade mais rica da América Latina, ela tem cerca de 3,5 milhões de pessoas vivendo em habitações subnormais, em favelas, em cortiços, em condições não dignas de um país que queira ser decente para os seus cidadãos. Quando nós olhamos a questão da circulação, as nossas cidades se perdem gradualmente, inclusive cidades até num patamar como Florianópolis, que também já tem dificuldades tremendas de locomoção e acaba sendo uma das principais reclamações hoje, se nós olharmos o componente econômico e de desenvolvimento econômico da própria cidade. Mas tentemos imaginar o que representa isso em São Paulo, no Rio de Janeiro, e outras cidades. E aqui estou falando só no caso brasileiro, mas isso vale para outras regiões do planeta. Quando olhamos esse C de circulação, que demanda, portanto, transporte e mobilidade, esse mesmo C é o C de caótico. Ao vermos a questão do trabalho, a necessidade de estabelecer a relação entre as distâncias, por exemplo, a serem percorridas, o tempo a ser utilizado por cada cidadão em relação ao seu transporte, nós verificamos que não trabalhamos a relação entre o transporte ser colocado em função de habitação e de trabalho, trazendo melhorias na forma com que a população que hoje utiliza horas, às vezes do seu dia, diariamente, perdidas numa atividade que poderia não ser realizada se fôssemos aproximados. Quando olhamos para isso, portanto, além do aspecto das dificuldades, dessas transformações que foram relatadas nas mesas nossas aqui de ontem e hoje, as transformações dos tipos de trabalho, assim sucessivamente, nós verificamos que isso significa algo que precisaria ser realmente equacionado e resolvido. E a recreação, o lazer, a necessidade de sabermos que isso é algo essencial à natureza humana. A existência de praças, de parques e assim sucessivamente. Então, quando olhamos para esse conjunto todo, eu termino aqui, que eu gostaria de abrir aos debates para a nossa comunidade. E, dentro disso, a conexão entre aquilo que pode e deve ser feito e entre aquilo que deveria ser planejado para reduzir depois os problemas que vão surgindo, se planejados fossem, nós teríamos, portanto, as condições de avançar para sociedades mais sustentáveis e mais justas. Então, eu coloco a abertura para os debates. Temos questões? Professor, a agricultura irrigada e o abastecimento animal representaram 60% do consumo dos recursos hídricos nacionais disponíveis em 2018, como foi apresentado na sua exposição. Muito se fala sobre incentivo e educação nas cidades, mas cabe aqui a pergunta: qual é o papel do Estado em modernizar esse setor de modo a gerar sustentabilidade? A pergunta, portanto, aqui feita pelo Vinícius Rosa.
Thank you. When I said 60% of water is used by agriculture, that is at the lower end. It's around, the global average is around 60 to 70%, but some countries like Pakistan uses 90% of their water for agriculture, and Pakistan is a very dry country. So the question was, what role can government play in terms of educating the people? I think it's a two-way street. What I mean by that is, there is only that much the government can do. In other words, they need to have various educational programs, extension services, etc. But the farmers themselves need to understand that water is a very precious resource. It's a finite resource. Of all the water that is on this planet, only 1% is suitable for human consumption. And of that 1%, we use 60 to 70% for food production. So we as citizens, we need to understand that the water is a precious resource, needs to be conserved. So it's not government alone, yes, education, extension, all those is important, but also farmers also need to be proactive and ensure that they use water conservatively.
Nós temos 1 minuto para concluir essa atividade e eu colocaria uma observação e solicitaria ao professor que pudesse colocar na sua experiência em termos de comparação entre aquilo que foi falado aqui, qual a relação entre países que vocês já estudaram e têm acompanhado, sob o ponto de vista se há semelhanças nos processos que envolvem a aplicação das engenharias e das questões ambientais que o senhor trouxe aqui para nós.
Yes, there is, to some extent, the problems, let's talk water, the problems are very, very similar. Though we think of different cultures, different societies, the problems are very similar, and to some extent we can learn from each other. And one of the biggest problems is we fail to realize water is a finite resource. It's only that much of water that is there on this planet. And I think solutions can be universal, but I think first and foremost, we need to understand the value of water. Did I answer your question?
Ok, acho que nós podemos então encerrar. Vamos agradecer ao professor Ashantha, por sua participação, pela sua aula aqui conosco e consideramos encerrado essa atividade. Obrigado.
Muito obrigado, agradecemos aos doutores. Peço para que fiquem aqui ao palco para que a gente faça